in a million. I think we got it clean. Now, tell me how to find Bacon Mug's secret files.
Huh?
Bacon Mug's secret files, you know, the ones with all his dastardly plans. I mean, that's the kind of thing we can expect to find here, right?
It is true that if I did have secret plans, they would also almost certainly be dastardly, yes.
Okay, so, Sheila,
I don't know.
what do you mean you don't know? I mean, this is your office, isn't it? It's supposed to be a job or something?
Hey, give me a break. I've been filled with coffee most of my life. What do I know from computers? I mean, most of the time I just move the arrow around so it looks like I'm doing something. Hey, Sheila, I was going to run down to the snack bar. Just wanted to see if you wanted anything. Get over here, Jasper.
Okay, so, we're not dumb people, or mugs here, right? I mean, how hard could this be? Suggestions?
Oh, what about doing a Spotify? I think that's try up, down, left, right, BA start. If we're looking for a thing in a certain spot, wouldn't that be what doing a Spotify is for?
Down. Look, first of all, none of that makes any sense. And second of all this whispering is turning me into a crazy person. Got it?
Yep, I got about it. Not to interrupt the think tank, but might I suggest the folder labeled Secret Files? Yeesh.
Well, that's a lot to wrap your head around. Bacon Mug, let's get out of here and regroup so we can figure out what our next move is going to be. Jasper, Sheila, you two, play it cool. This thing is far from over.
All right, good morning, guys. I want to let you know, you may have noticed that the last couple of days I've been slicing things up into really small pieces, and that's because we've only got 4 or 5 instructional days left. And so where I want you to end is with a couple of concepts that you can really cement and go home and understand for when you come back in the summer. So I know nobody's probably complaining about it, but that's why everything's been sliced up so small. So yesterday, we talked about this idea of completing the square. And remember, as a quick review, we said we needed to have our variables together. We needed to have an x squared and then a coefficient times an x. And then what we did to finish that square out and be able to factor it is we were going to divide, and you're going to work on that some more today, don't worry. We would divide that b by 2, and then we would square it. We're going to do that in a second here to remind ourselves of how this works. But now we're actually going to use that to solve equations, which means we have to have the equation in the right form before we can do anything with it. And the short version on that is this. Whenever I'm solving by completing the square, I have to have the little tool, the piece that I'm going to use to complete the square by itself on one side of the equation. And so if you notice right now, don't be fooled by this plus 3. We might think, oh, can I factor this out? You could try all day long and you could never factor it out into a perfect square. So the very first thing we need to do is get those two pieces by themselves. So if you ever see one that's like this, and it asks you to solve by completing the square, start by taking your constant and moving it to the other side. So I'm going to leave some space here so we can do this. All right, now you've got a problem that looks a lot like what you were doing yesterday, right? So we've just got to fill in this last part, then factor it out and solve for our 2 answers. So remember, how do we do that? There it is hiding up there. We find our b, that's 6 divided by 2, that's 3, and then we square that number, and 3 squared is 9, and we just add that on to the back. Okay, now we've got something that we can work, except that I'm going out of my mind, and you have to add something to both sides of the equation or else it doesn't work. My brain was telling me something was very wrong there. All right, so we'll deal with this in a minute. We know that that is going to be 6. I'll go ahead and write that out for you now. So now we know we need to factor this into a perfect square because we've got a perfect square trinomial here. So remember, we're going to have something in parentheses, x plus something. Very easy to do, and some of you guys have figured this out already, that once you divide this in half, you usually know exactly what that other part is going to be. So we get x plus 3 squared equals 6. Still not done yet, getting closer though. square root of both sides. Now remember, we have to solve for both versions. So we know that the answer could be positive square root of 6, or this could be equal to negative square root of 6. Pretty simple here, we just solve both parts. Subtract 3 from both sides of each one. On this side, we get x equals negative 3 plus square root of 6. On this one, we get x equals negative 3 minus square root of 6. And then the way we write that simply is negative 3 plus or minus square root of 6. That's the simplest way to write that. So the only step we had to add, the only thing that was different than anything you were doing yesterday, was this part where I had to move this constant to the other side. Remember, unless I have these by themselves in the place that I need them, I can't use completing the square to work with them. Oh, so good news over there. Take a look. Hey, is there any first step we need to take there? No. We've already got x squared plus 10x by itself on one side and our constant on the other side. So we can go straight to completing the square. So let's look. What's our b? Hopefully everybody feels good about the fact that that's 10. We're going to divide 10 by 2. That gives us 5. And then we're going to square 5, and that's going to let us know we're going to add 25 to both sides. So this side is going to be 11. Now we've got to factor out that perfect square trinomial. What does that break down into? What is the perfect square that multiplies to give us that? X plus, I'm going to leave that blank for a second so you can think about what might go there. Remember, if you're not sure, FOIL it out. If you said x plus 5, good job. All right, now it's time to solve. Square root of both sides. So we get x plus 5 equals square root of 11. And we get x plus 5 equals negative square root of 11, because remember, either of those can be correct. Subtract 5 from both equations on both sides. Here we get negative 5 plus square root of 11. Here we get x equals negative 5 minus square root of 11. And then to write that efficiently, we write x equals negative 5 plus or minus square root of 11. So again, little by little, practice with this, because I'm going to tell you what we're going to talk about tomorrow is going to seem crazy, but it is so key for where you're going. Okay? So pay attention tomorrow. Really try to reinforce this stuff. Come to live conferences this morning if you're not sure about anything. However you choose to attack it, hope you have a great day, and I will see you tomorrow.